No? The way the
Numbers should be fine, so they just correspond to that one in the IDAT file.
Oh.
So that's what so Genome Studio, so then genotype in, next, I'm going to change that to
Desktop. Yeah, that's the
in
one.
there, and we'll call it, so say select folder. So all you're doing now is just placing the Genome Studio file into there, and we'll do Genome Studio, I'll stick my initials there, next. So you use sample sheet to load up sample intensities, next. And then the sample sheet is, just click that one. The data repository, so that's your IDAT file. So just select that one. And then the manifest. Your manifest is just this folder here. Then you press next. And then import cluster file. And then cluster files. And then clicked on the EGT file.
The manifest, did you put the cluster file?
Yeah, he did,
So
because
it
it's
says,
inside.
yeah, so that's the BPM one, so that was
Okay.
inside. So what you do is on the sample sheet, see if I've got a copy of the sample sheet here. You have there under the manifest the name of the
Yeah.
file,
Oh,
the BPM,
okay.
and it
Okay.
automatically finds it. So
Okay.
essentially, if you're running like several different array types, it will just pick the most appropriate manifest from
Okay.
there.
You saved it inside that.
Yeah, that's fine.
So if you then click yes to import cluster file, select the cluster file, and then you need to go for calculate sample and SNP statistics. So select that, and then finish. And then you want it to stay there for a few seconds. If it just immediately goes green, it means there's an error, but that's just loading up now. While that's loading, I'm just quickly going to get my samples just for 1 second.
After this, when you go, you can take your magnetic beads. I'm done with it.
So it's the slowest software ever, Genome Studio.
Nathan said we can use even blue fuse for it. But Kim said she couldn't open it in the blue fuse.
I don't know.
You have to try.
One of the software is they developed it in like 15 years ago when the arrays had like real small content, and now they've kind of like quadrupled the amount of content, but they haven't updated the software.
Makes sense. So we've gone back to the old age.
Yes.
So blue fuse must be the advanced one.
So the blue fuse is specifically the carrier method one. This
Okay.
is just the generic. So Genome Studio is what all of the sample QC is done.
Okay.
There's built-in QC probes,
Okay.
which you can only access from Genome Studio. So it's kind of like the one kind of size fits all.
All right. Okay.
format.
Okay. Yeah, that's fine.
So, yeah,
It
it's
should be
good.
like, yeah. Just pause.
So I'm just going to open this up. Is just to check that it's the core rates are good enough. So if you just click on this core rate section here, and then go up. So that one's failed, but anything kind of above 95% is a strong pass. So kind of 95.8 there, 95.9.
Yeah, good.
So they should all be okay. And then just check the clustering as well, just to make sure that that's right. So you'll probably need to go down to where you see the RS numbers, so just the individual SNPs, and just click on a couple of those just to check the clustering. So essentially the little cross in the middle is the true value for that allele, for that genotype. So the clustering's slightly off, but it's probably because you're using a CRISPR edit.
Huh? You shouldn't
Say it
do
again.
So essentially so for the true value for the genotype is that small little red cross, and there's a purple cross and a blue cross. So you just want to see that it's clustered to that. But the way that they kind of find the true value is by genotyping kind of like a North American population. So if you have something that's slightly outside of the North American population, so something like a different ethnic group or like CRISPR edited cells, they'll be slightly off that true value, but you kind of want to still make sure that the majority of your samples.
Why should the CRISPR edit be of different value?
Because it affects the intensities of what it is. So essentially all the IDA is it just reads the intensity of the fluorochrome as you shine a laser
But
on it.
CRISPR doesn't do anything.
But it changes the levels of the intensity. So if you have like indels or kind of bits of
But
the
it will be in
genomes,
only one area of the genome.
and yeah, it kind of, so the way that it normalizes out all of the intensities afterwards,
Okay.
it kind of affects that.
Right, okay. So you mean like two different edits. So it's calculating the intensity of all the samples together.
Yeah.
So where the control is, so there will be like two types of cell line there, hex cell line and IPS cell line.
Yeah, this one.
So there will be like two different cell lines, right? So this is the IPS line. So there are two different cell lines.
But
Probably
there-
that's because of the lines. This is human IPS line and this is the cancer cell line. So is it probably because of that it's been...
It might be that doesn't look too bad. Some of them didn't look full. It's these
yeah.
ones here. So these are the individual SNPs, not the patients or the cell lines.
These
So-
are cell lines.
Oh no, so we're looking at this one here. So these are the individual.
Yeah, individual SNPs, yeah.
So the individual SNPs. So they haven't clustered fantastically because there's some on the outside. That's probably because you've done.
Can we eliminate the second line?
You can't eliminate them.
We have to create another project.
You'd have to recluster them if they were too bad.
Can you recluster only the IPS line?
The problem with reclustering is it takes about 2 weeks. You'd have to make a custom cluster file. So you can ask it to recluster now, and then you have to go through and check every single one of
2
the
weeks,
SNPs.
yeah?
Yes, it's 635,000